Good day everyone. Welcome to my presentation. I am Captain Ron Irani and I wish you all a very happy 2021. In this video I will be explaining the solution to problems 9 and 10 on pressure and thrust from Captain Subramaniam's textbook, exercise 1. Problem 9 states a rectangular deep tank is 22 meters by 20 meters by 10 meters. Above the crown of the tank is a rectangular trunkway 0.2 meters high, 5 meters long and 4 meters wide. Find the thrust on the tank lid when the tank is pressed up with salt water to a head of 2.64 meters above the crown of the tank. So let us refer to the drawing which has been made basis the data given to us in the problem. We have a rectangular tank, 22 meters, length 22 meters, breadth 20 meters, and a height of 10 meters. On top of this is a rectangular trunkway 0.2 meters high, 5 meters long, and 4 meters wide. We have to find the thrust on the tank lid when the tank is pressed up with salt water to a head of 2.64 meters above the crown of the tank. Now, when this is mentioned to us, it is as if there is an imaginary tank that is placed on top of this existing tank. The height of this imaginary tank is 2.64 meters and it is also filled with the same liquid, in this case salt water. So because of this is this head of the water in the tank, we have to find the pressure and thrust on top of the trunkway, which is equal to 2.44 meters in height. 2.64 meters is the height of this imaginary tank from the crown of the main tank. So let us see the solution of the problem. Height above the trunkway is equal to 2.64 minus 0.2 is equal to 2.44 meters. Pressure above the trunkway equal to depth into density, that is 2.44 into 1.025 equal to 2.501 metric tons per square meter. Area of the trunkway is equal to length into breadth, that is 4 into 5 equal to 20 square meters. Therefore, pressure experienced on top of the trunkway is equal to 2.501 into 20 equal to 50 metric tons. Going on to problem number 10. Problem number 10 states a double bottom tank measures 25 meters by 20 meters by 2 meters. Find the thrust on the tank top when pressed up to a head of 16 meters of salt water. Also find the resultant thrust on the tank bottom and the direction that it acts if the ship's draft in salt water is 10 meters. So here we have the double bottom tank, length 25 meters, breadth 20 meters, height 2 meters. It is filled with salt water and it is pressed up to a height of 16 meters. That means from above the tank top there is 16 meters of water. Now a double bottom tank is on the bottom, is below the cargo holes, whose height, the height of the double bottom tank is given as 2 meters. So it is as if that there is an imaginary tank that is placed on top of your double bottom tank, and the height of that imaginary tank is 16 meters, having the same area, length and breadth 25 by 20. Now consider this air pipe or sounding pipe. Even though the diameter of the air pipe or the sounding pipe is small, the volume of the salt water or any liquid within that pipe will be very minimal. But it is construed as if there is an imaginary tank existing on top of your double bottom tank of this same height, and it is full of that same liquid. So on that basis, we will be working out this problem. Another data that is given to us is that the ship is floating at a draft of 8 meters. No, it is floating at a draft of 10 meters in salt water. That means this is your water line at a draft of 10 meters, and since the height of the double bottom tank is 2 meters, so above the double bottom tank, your water line is 8 meters. Above the top of the double bottom tank, the height of the sea outside is 8 meters. So pressure on the tank top. Okay, sorry. Area of the tank top and area of the tank bottom will be the same. That is 25 by 20. That is 500 square meters. Pressure on the tank top is equal to depth into density. Now the depth here is 16 meters because it is pressed up to a head of 16 meters. That is from the top of the double bottom tank. That is equal to 16 into 1.025 equal to 16.4 metric tons per square meter. Whether there is a full tank resting on top of your double bottom tank or there is just a minimal amount of liquid within the air pipe and sounding pipe, the pressure and thrust acting on the tank top will be as if there is a full tank sitting on top of your double bottom tank. The thrust on this tank top is equal to pressure into area equal to 500 into 16.4. 500 we have calculated the area of the tank top, and 16.4 is the pressure on the tank top equal to 8,200 metric tons. Pressure on the tank bottom. For pressure on the tank bottom, we have to add this height of the double bottom tank to 16 meters because it is from the top of this sounding pipe or air pipe. It is from the top of the head that is mentioned to us as 16 meters. So the head on the double bottom tank bottom is equal to 18 meters. So pressure is equal to 18 times 1.025 equal to 18.45 square meters. And thrust on the tank bottom is equal to pressure into area. Pressure is 18.45 and area we have seen above over here 500. So thrust on the tank bottom is equal to 9225 metric tons. The pressure acting on the outside of the tank bottom, that is on the keel. Now where is it coming from? From the sea. This pressure is coming from the sea. Sorry. Let me just show you. This pressure is coming from the sea. And that is equal to the draft. The depth here is the draft. The draft given to us is 10 meters. That is 8 meters above the tank top plus 2 meters the height of the tank. Depth into density or the draft into density and that is 10 times 1.025 equal to 10.25 metric tons per square meter. The area of the tank bottom we have calculated above equal to 500 square meters. Therefore, the thrust acting on the tank bottom is pressure into area, that is 10.25 into 500 equal to 5125 metric tons. The resultant thrust now is the difference between the thrust on the tank bottom 9225 and the thrust acting on the tank bottom upwards from the sea equal to 5125 metric tons, which gives us the answer to be 4100 metric tons. Now, just another simple exercise. What would happen if there was no additional head of 16 meters? Exactly the same problem we are going to work out without this head of 16 meters. It's just that the double bottom tank is full and your ship is floating at a draft of 10 meters. Everything stays the same except that there is no head of 16 meters of salt water acting on the tank top of this double bottom tank. Going on to the next slide. There is no head, as I told you. So the height, above the tank top, the height of the liquid in this pipe, in this imaginary tank that is existing on top of your double bottom tank is equal to 0. Therefore, the pressure acting on the tank top is equal to 0 times the density equal to 0 metric tons per square meter, and therefore the thrust acting on the tank top is also equal to 0 metric tons. The pressure on the tank bottom is equal to depth into density. Depth now is just 2 meters. There is no head of 16 meters existing anymore. So on the tank bottom, it is just depth of 2 meters multiplied by density equal to 2.050 metric tons per square meter. And thrust on the tank bottom is equal to 500 times 2.050 equal to 1.025 metric tons. Pressure acting on outside of the tank bottom, that is the keel. Let me get these arrows back here for you. So pressure acting on outside of the tank bottom, that is the keel, equal to pressure depth into density equal to draft into density, and that is equal to 10 times 1.025 equal to 10.25 metric tons per square meter. Thrust is equal to pressure into area. This is the thrust that is acting on the bottom of your tank, on the keel of your ship. That is equal to pressure into area equal to 10.25 into 500 equal to 5125 metric tons. Thus, the resultant thrust acting upwards is equal to 5125 minus 1.025 equal to 4100 metric tons. So in this case, the thrust acting from the sea onto the tank bottom is greater than the thrust acting onto the keel from the top, from the salt water that is in your double bottom tank, and that is equal to 4100 metric tons. And what we saw in the previous problem, the thrust that is acting on the keel from the top, which includes the water in the double bottom tank, plus the head of 16 meters minus the thrust acting on the keel from the bottom from the sea is also equal to 4,100 metric tons. But there is a major difference in this. In this solution, we have a head of water of 16 meters. Therefore, the direction of the thrust is vertically down. And here, without the head of the water, the thrust is acting vertically up, even though the values are the same, because the thrust from the sea is more than the thrust from the water that is in the double bottom tank. So my dear friends, it is very important that when you fill up your tanks, do not have any water going into your air pipes or sounding pipes, because the tank top is not made to withstand such a pressure and thrust. It is far too excessive for the tank tops. So try and restrict your ballast only until the tank top, with nothing coming into your air pipe and sounding pipe. It is as if you have put an imaginary tank full of water or any other liquid sitting on top of your double bottom tank. Thank you very much for your kind attention. If you liked the presentation, give me a thumbs up, like, share the video, as well as subscribe to my channel. Thank you very much. Goodbye and stay safe.